Last time we talked about the geosphere, the origin of the planet and the plate tectonics. We're now going to look at what are the results of plate tectonics. Those are earthquakes and volcanoes. Earthquakes are very, very devastating, as seen as this picture. There are over 30,000 earthquakes that occur worldwide. However, most of them are not very strong. It's sort of like a truck driving by. However, there are approximately 75 of them per day that are above 3 that are actually big enough to feel. The one off to the right is the 1906 San Francisco earthquake. That was about somewhere between a 7.2 and 8.5, and it took 1.2 seconds for that straight line fence to be offset like it is. It's one of the most destructive forces on Earth, not because of the actual shaking, but what happens afterwards. The falling of the buildings, the tsunamis, things like that. It's secondary effects that are the most destructive. So, for example, if we look at the Soviet Armenia, it's very, very destructive. It was not a very big earthquake, only 6.9, but 25,000 people died. Why so many in this one? We'll get to a couple. In 1985, there was a Mexican quake almost 15 times as big, where only a third of the people died. In 1995, 1/4 of the people died. Same magnitude as the 1988. And then if we look at the Loma Prieta, same size, only 40 people. The difference was multiple things. One is the building code. The Armenian one happened in the outlying country. The building codes were not very good, and it was the middle of the winter. Therefore, the buildings fell down, and then a lot of the people died due to pneumonia. Whereas the Loma Prieta was, the building codes are very, very high, and it's Southern California. The earthquakes are gauged on something called the Richter scale. The Richter scale is the logarithmic scale, which basically means if you go from 5 to 6, it's 10 times as much shaking. And therefore, a 3.0 is basically a truck driving by, a 4.0 is 10 times, a 7 is large enough that you will not be able to walk across the floor. I know because I tried during the Landers quake and I've landed on my butt. If you go anything beyond 7, however, they do get slightly smaller, but the main difference between a 7 and a 9 is not necessarily how strong it is, but how long it shakes. The 7.1 Loma Prieta was only 15 seconds. The San Francisco, the 8.5, was somewhere around 40 seconds, whereas the Alaska 9.2 lasted 4 minutes. That's scary. Now, one of the definitions that most people don't understand is the difference between an epicenter and the focus. The earthquake actually happens at the focus. That's where on the plate boundary the shifting is actually occurring. The epicenter is what is directly above that on the ground, where humans would be able to see it. Now, there are 3 basic types of earthquakes: extension, which don't occur very often around here; compression, where you're going to get mountains built up, where you're going to get the oceanic, you're going to get the trenches, you're going to get the volcanoes; and the transform, which is the San Andreas, where one goes by the other. There are 3 the basic mechanism is that after the last earthquake, everything is fine. However, through time, for example, since the San Andreas happened 150 years ago, the one side of it has been moving by the other at the same rate that your thumbnail grows. That doesn't seem like much per year, but it's been 150 years. How much would your thumbnail grow in 150 years? Eventually, that strain is going to build up and build up and build up, and it's going to release all at once. When it does, you're going to get spring going back and forth, and that's basically what it feels like, is a spring going back and forth. Now, when this happens, we're going to have 2 types of waves The P waves are the primary first wave. Why? Because they're traveling at 15,000 miles per hour. They're compression waves, like you're taking a slinky and moving them back and forth at 15,000 miles an hour. Kind of fast for a slinky. The other types, that is what you see at the top here, is the P waves. They're compressed very close together because they're traveling so fast. The S wave, on the other hand, is the shear wave, the surface wave, sort of like you're doing a rope up and down. It's slower than the P wave. It's going to come in second. It typically goes across the Earth's surface. That is where you're going to be bouncing up and down. It's the one that causes the damage. It's the rolling feeling you have at the end of the earthquake. And that is what you see down at E, where you've got the S waves. Here it's like the slinky with the P waves. Now, how far away is it? When locating the epicenter of the earthquake, it's just like what you do when you see lightning. You start counting, and when you get to 5, you know it's 1 mile away. When you get to 10, it's 2 miles away. Same thing happens with an earthquake. You've got the primary wave that first nudges you, and then you have the second one, the surface wave, coming in. And so the distance between where the S wave hits, the P wave hits, and then the S wave is going to determine how far away it is. And so you can see here, if you're sitting right here, you would know that you had an earthquake that is 4,800 miles away, but you would not know where it is. And so what we have to do is we have to use triangulation, where you use 3 epicenters based on the seismograph, and you take where the 3 of them cross, and that is where the epicenter. So this one right here, this is where the seismograph, and they knew that it was someplace along this line. This one, here's where the seismograph, and we knew it was along this line. Between the 2 of them, we've got either this spot or this spot. And then with the 3rd one, we knew exactly where it was. That's how you find out where they are. The distance away from you, and then the triangulation with the 3. Now, what are some of the primary effects of an earthquake? 1, you get shaking. Shaking. Now, this one is fairly bad because it was in Alaska during and remember, Alaska has permafrost, so anything below 4 feet down is going to basically be frozen. And when it shakes, it breaks like you're breaking up China. Huge chunks are going to happen. Where you get, this is a highway being pushed together. This is what happened with the Northridge quake, where the building that fell down. This is the San Francisco quake of the mid-90s, the early 90s. This again, what happens, it falls over. This is the Landers quake of 92, where it shifted sideways, where one side was, the side closest to you is moving north, the side farther away from you is moving south. It used to be the straight road between Landers and Arizona, now it's not. The buildings collapsing like that. Now the secondary effects can be worse. Basically in 1906, the fire that occurred was much more devastating than the earthquake itself. Buildings were devastating. Why? Because they had basically ammunition in the same buildings that they had a lot of combustion material. That started the fire and it took off. Another thing that happens are land slides, where this is one where the landslide came down and covered up the road down below it. Landslides can also occur underwater. When tsunamis happen, it's because of either landslides or a type of a slippage because of a convergent plate with the oceanic and the landmass. And so what happens is with the oceanic one is that this goes underneath here, and it builds up pressure right here. And when that releases, goes back up here, it causes a wave to happen. Now notice up here, this water is going this way. When it goes away, that is one sign that if you're on a beach and all of a sudden all the water starts flowing away from you, that's really weird, but it's also a warning that there's a tsunami happening. Why? Because the water's flowing out, but it's going to come back, and when it does, can be fairly high up and do nasty things to you. Another thing that can happen is what happened in Chile, is where they had an earthquake and there was a landslide underwater. When that happened, basically the same thing happened, where they had the water being drawn down here, and therefore it was being pulled away from the land. Then it came back, and when it goes up over land, when it's out in the middle of the ocean, it's not very tall, but when it's going up over land, it builds up and up and up, and it becomes fairly deep. Now this video right here is showing what happens at the very beginning, where basically you can see in this one, all along the front, you can see that open sand. Why? Because it's all being drawn out. You can see the huge waves that are occurring coming into shore. And as they're coming in, they're not going to stop. They're going to keep on coming, and you're going to see they're coming and coming and coming, and they're going to flow into the building, and they're going to continue going. Okay, and again, another set of waves coming in even higher that are going to do more damage. Now, volcanoes. What happens with volcanoes? Volcanoes are basically where these are the modern ones. As of a couple days ago, this is the location. And notice that they're all along the line of plate tectonics, about where the plates are. Now, there are two things that you need to know. There are extrusive igneous rocks. Those are the ones that come out and are going to solidify fairly rapidly. But there's also something called pyroclastic material. You've got the pyroclastic, which shoots up into the air. And then you've got the magma that is going to flow down the sides. This all comes from something called the crater. That is the depression at the top, which vents out the magma from the below. And so basically what we have is we have the lava coming up, and it sits under here. And slowly there's a buildup of time, more and more pressure, and all of a sudden it's going to go up. Now if it goes up into the cloud, it's going to be pyroclastic. If it goes down the side, it's going to be lava. It's going to be the igneous rock, the extrusive igneous. Now, there are three different types of volcanoes. There's the shield volcanoes. These are the ones where they flow up and gradually come down. They don't have explosions. This is the volcano in Hawaii, where it comes up and it just goes over time and flows in all directions. It's not explosive. Another type of volcano, however, are called the cinders. They're the ones that erupt, and they go high, they go up into the sky, as you can see right here, and they build up rapidly. They have very steep slopes, not the gradual like the shield ones, but you've got very tall ones, and you've got lots and lots of pyroclastic stuff that's flying up into the sky. Now, this is a composite, which is somewhere in between, where it's got, sometimes it does the slow stuff, sometimes it has the eruptions that are very nasty, like the cone. These guys take a long time to develop. This would be like Mount St. Helens up in the northeast. And so again, through time you get more and more buildup. You've got the lava coming up, and you've got air bubbles. And up in here you have a plug. And eventually the plug is going to be destroyed. And that's when you're going to have, when there's enough pressure, and that's where you're going to have the volcanic eruption. And again, some of the things that you can do is you may want a seismograph around the volcano. Why? Because that's going to give you warnings of when this is going to happen. Now, this is what happened with Mount St. Helens in 1980. This is beforehand. This is where it's starting to go, and this is where it's nuts. Now, one of the things you need to understand is that as this goes up, it's drawing the air up very, very rapidly from the sides of the volcano. That's going to cause some other effects. Again, it's going up, and you've got this massive cloud of pyroclastic sand basically all over the place. This is one of the devastating things that happen because of all the air going up and up there. These trees, which are 3 or 4 feet in diameter, are basically pushed over because of all the mad rush of air. Then when the air comes back down, they're pushed back in the other direction. Now, when a volcanic eruption occurs, this is one of the smartest things to do with your truck or car. Cover it, because if you try to rub off the pyroclastic material, there goes all your paint. When you try to wash it off, there goes all your paint. It's nasty material. This is what happens at the top of Mount St. Helens afterwards, where basically it calms down and it may have a slight vent which is releasing some of the steam. Sometimes when volcanoes are very, very huge, very, very old, they will form what's called a caldera. That is where it's basically the volcano has collapsed, and basically you get something like this. This is the Yellowstone caldera. It erupted 640,000 years ago, and this is a caldera whose crater was 30 to 45 miles in diameter. When it went 640,000 years ago, some material from this landed in New York State. And that's all we have for this section of the geosphere.